Okay, looks like we're having a little bit of trouble here trying to figure out exactly how to convert an equation into a Python function. So here I've just sort of created this standard function that you might have in any algebra class where the output is going to be graphed. And we're going to convert this into something that might be a little bit more useful in Python, yet still sort of represent the same kind of event. So the first thing to notice right off is we have a value f of x, which indicates it's going to be graphed, and we're not going to graph. What we're just trying to do is come up with a very precise number. So we don't need the f of x, but let's go ahead and just stick this as it is directly into the Python interpreter and see what Python has to say about it. All right. So f of x actually appears to be a valid Python name. However, it's not going to work like an f of x. You know, you're not going to be able to create a value for x and get a result for y out of it. So we have to convert this into something that makes more sense. It's more Pythonic, basically. So let's go ahead and just get rid of the idea that it's going to be graphed altogether, and we're just going to provide concrete values for x and z there. So the equation we have is 34x plus x to the power of z divided by 15. So x and z are the two variables inside of that equation. We're just going to give them static values. I put them into my interpreter. Now if I print those, there we go. Print x gives me 4. If I print z, that's going to give me 3. 1, 3. All right, excellent. Now, instead of having f of x, I'm just going to change that value to y. All right, so I have static values in there now, and I'm just going to plug this in here. I've got to upload that value directly into y. Oh, syntax error. Okay, so that's not going to work, and the reason it's not going to work is because you can't put 34 next to x, right? That's an invalid one. It's an invalid variable name, which is sort of how Python's trying to interpret it at this point. But also because what we're trying to do there really is multiply the integer 34 times the value of x, and if we print x, we get 4. So we know that those are multiplication of 34 times 4. All right, so we need to go through and correct that syntax, and here is that equation with completely correct syntax. Y equals 34 times x plus x to the value of to the z divided by 15. All right. So now we have a valid value within y. So if I print y, it's going to give me the value that was determined. Now if I change the value of x, so we're going to say x equals 6, and now I'm going to go ahead and print y again. Now ideally that would update the value of y, right? But it doesn't. And the reason it doesn't is because y contains an integer. It doesn't contain a function. So that means we need to change things so they act with a function. So here we're going to define an equation EQ. We're going to pass it the values x and z, and we're going to return this function right here. And here, this is just our math function. We've transcribed it from back here, and it's gone through all the sort of iterations to get it to where it needs to be, and we're going to return that value. So let's go ahead and put that into our interpreter. Enter. All right. Now if I call it EQ, and I pass it the values of 4 and 3, and I print that out, I get 13. Now let's go ahead and change that to 6. Excellent. So we are getting our equation updated. We've got it stored in Python in a way that we can hand it different values and get different results out, and that's it. That's all there is to transfer. We can go ahead and take this and see what happens if we plug that into Code Sculptor. Just have to get it in the correct paste buffer though. And we'll run that. There you go. Now let's change this to 3, just so you can see here. We'll run that, 3 and 4. And that's interesting.